Hello everyone. Today I will be using a program called GeoHECRAS to review and potentially modify a hydraulic model of a river that is flowing through one of our clients' properties for the purposes of confirming or verifying the flood line that's on the property and establishing the development limits. What I have done so far is I created a new project and I saved it under the name Pine River. And since we have already been provided with a kind of high-level approximated model from the Conservation Authority, the next thing I will do is I will import that model into GeoHECRAS. So go to import data, import HEC-RAS project. Here I can select the name. I've previously saved it under the folder NVCA model. This is the name of it. I can either select all scenarios or select which one I want. It looks like there is only one, so we'll go all scenarios anyway. And we'll use real world coordinates without scaling. Just to make sure that the model actually runs the way it was provided to us, and that is to make sure that there are no errors already present in the model. I'm going to run an analysis just using this imported model. So we'll go compute steady flow, current scenario. There's only one flow profile, so we'll just click compute and see if the program runs. Everything seems good, so we can close it and we know that we have a working model. Okay, so since we want the model to be located at the right location globally, we want to make sure that the coordinate system is the correct one that's used in our area. So here I can see it says local HEC-RAS, so that's not what we are using. So if we click on that, and I've already pre-saved the area that we are located in under favorites, and it should be this one, NAD 83 UTM 17. Apply to map view. Okay, and now the right coordinate system is displayed on the screen. So the way to verify that it's at the right location, I'm going to open a Google image behind the model and make sure that we are at the right location. So we'll right click here, add base map layer, and we'll just select Google Aerial. Okay, and it looks like things are lined up correctly. I have viewed this map before, so I know that it is at the right location. So now we have a existing model from the Conservation Authority shown on top of a Google image. In addition to the HEC-RAS model, we have also been provided with some GIS data by the Conservation Authority. So I'm going to try to import that and see what the extent of the data is and how it matches with the model. So again, right click on this panel here, add layers, and this is where I put that the GIS data, select all, and go click open. And we get an error message here. So it says that we should have named the file with a GDB extension. But so let's see if the program can handle this and make the necessary corrections. So we'll get a few error messages, but at the end the GIS data is imported, and if I click on that, I can see that you can really see that that was the river, There are some water courses in the area. These are the mass points, so these are the actual points within the GIS. So it appears that for the reach that we need to model, which is this reach, there is enough GIS data to work with. What I would like to do next is use the GIS data to generate a terrain file for the area that is covered by the GIS. So I will go under terrain in the menu, generate terrain. The source will be GIS data, and the layers that need to be selected are the ones that have a Z coordinate. So that would be these first two. I would like to generate the terrain over the entire extents of the GIS. So I'll pick this elevation source extents. The terrain file, I would like to name it similar to the source, so NVCA GIS data terrain. Here I believe this is where the file name goes, so go back to the project folder and save it under the same name. This is correct, and we'll just leave this as ultra high resolution, see what happens, and click generate. Okay, so it has created a layer of the name that we specified. Now to see if it actually worked, well, we can turn off the GIS, and when I have my cursor in the area that was covered by the GIS, I can see that at the bottom here it shows the Z coordinate, so it looks good. What we can do is, if we go under this terrain layer, click on this, and we want to show an elevation color fill, so just pick that. No need to change any of these colors for now, we can change that later. Click OK, and that should generate a color scheme, but it's not visible now because it's covered by this Google image. So I need to unclick this, and it shows the color scheme. So whatever's light green is lower, these darker colors mean that it's a higher terrain, and again it's showing the Z coordinate at the bottom here. So that's what that layer is. So what I would like to do next is to use the terrain to generate contours, so that these can be used for cutting the cross sections later. So again, under terrain, generate contours. This is the project folder that's already selected. Here we're going to call it something similar to the previous layers, so we know what that information came from. So NVCA GIS data contours. We are using the NVCA GIS data terrain override. I don't think that needs to be selected. It doesn't matter. We'll leave that as is. Here the contour limits, we will use the terrain surface limits. Minor contours, typically what I want is, I want the major to be 1 meter and the minor to be, depending on how flat or steep the site is, typically I would like that to be 0.2 meters or so. So we'll select 0.2 meters for minor contours, 1 meter for major. This is the elevation difference that the program has read from the file. This is the correct zone, and we'll just click generate. And this will create contours. So if I turn off the terrain layer, I can see that there are contours now generated based on the GIS data and based on the terrain file. Okay, so this is pretty much all that I'm going to do with this existing model that was provided to us from the Conservation Authority. Any revisions to update the model or increase its level of detail will be done in a new scenario which I'm going to create. It will be called an existing scenario because it will reflect the existing conditions with some corrections and adjustments to bring the model to engineering standards. So I'm going to go up here under Scenario Manager, click on Duplicate Current Scenario, and I'm going to name this one. I'm going to zoom in a little bit to the reach that I'm mostly interested in, and that is between this crossing and this crossing, because our client's property is sort of in this area. So what we'll be doing is we'll be checking the model mainly within that reach, and what I see here is that there's a junction at this point, and there's another junction just downstream of this crossing. Now when I open this existing crossing here, I right away I noticed that there's something wrong. It doesn't reach far enough. It kind of ends right at the bridge opening, and also the size of the bridge opening on the downstream side looks much different than on the upstream side. So there's something wrong here. This is not the width of the bridge. When I zoom in, it's about 2 meters wide. The crossing is about 20 or 30. So I know right away that there's something wrong. First of all, the cross section is not long enough, and the bridge opening is not long enough. Also, we were advised by the local road authority that there are 2 additional culverts across this crossing. They're I believe 1900 CSP culverts that act as relief during flood conditions. So we're going to add those in as well. So what I'm going to do is I will close this, and instead of fixing it, I would like to start from scratch. So what I'm going to do is I'll just delete this bridge geometry, and I'm going to delete these two cross sections, and this one as well, and I'll code them in separately. Also, what's kind of messing things up is that there's this little creek here running across that roadway, or underneath that roadway, and it's joining up right at the downstream side of the bridge. So I think, and the reason why that section was not modeled long enough is because these sections are in the way. So what I'm going to do, and I hope it doesn't mess up the model, is I'm just going to delete these 4 cross sections and this reach altogether. Try to join these two, because I really don't need to know what's happening at this cross section, because I'll model the creek, and I need to know what the water levels are along this reach here, but I'm not really interested in what's happening on this little water course. The flow rates should still be maintained because they're assigned at this cross section here. Once these 2 reaches join up, the flow rate is indicated at this cross section, so that should not be impacted, but we'll see what happens. Okay, so I'm going to save the model just in case we need to go back, and I'm going to start deleting these cross sections. Second one, third one, fourth one, and I want to delete this reach altogether, so we'll go delete. Okay, good, yes. Alright, and now I'm going to try to run it. I think there will be an error because the way this junction is coded, it expects two creeks running into it and one out of it, which is no longer the case. But we'll run it and see what happens. So analysis, compute steady, current scenario. Okay. So scenario contains one undefined junction that is not supported in HEC-RAS. In order to determine the junction type, 3 or more river reaches must be connected. So somehow we need to figure out how to join those two reaches so that the program does not expect an additional stream being joined at that location. What I have done is I wrote down the boundary conditions for these two reaches, just so I have the information so it doesn't get lost. So if I click on this reach here, which is pin 14, I can go on the steady flow data, and I noted that there's a downstream boundary condition is that on the downstream side it's connected at junction 106, on the upstream side connected at junction 107, and there's a flow data point at this cross section. Also, I did the same thing for this downstream reach. On the upstream side it's connected at 106. Downstream side it's the end of the model. That's the start of the model, or the end of the model, whichever way you look at it. There's a known water surface elevation of 232.32, so I wrote that down. Upstream side of that reach, there's junction 106, and there's one flow change point at this cross section here, which is just downstream of the crossing. So we know that. So what I'm going to try to do is I'll click on this junction and I'm going to try to delete it. Okay, so now the entire reach is a single reach now. It renamed itself to 14, which was previously the upstream reach. And let's see what the boundary conditions are. So the upstream point is junction 107, which is this one here. That's correct. And the downstream is missing. Okay, so we need to indicate the known water surface elevation, and the number was 232.32. So now we know that the upstream boundary is junction 107. Downstream is the beginning of the model. We have a known water surface elevation, and we are might be missing some flow data. So we know that before the junction was deleted, we had a cross section 34,621.51, and that's the correct flow rate. And then 33,581.81, that's correct, has this flow rate 229.025. So that's all sounds correct. So we'll click OK, and we'll try to run it and see if it still runs. Okay, all seems good. So now we have a working model, and then we can re-enter this crossing into the model and model it properly according to as-built design drawings, which were provided to us by the local municipality. Next, what I will do is I will return the crossing back into the model based on the contours that we have, but actually what I'll do is I'll skip a step here because I did the modeling previously and I had some issues with the model, so I decided to redo it. but at least I'm going to show how to transfer an item from one model to another. So this is the current one we're working on. Here's an older one, and we actually have the crossing defined by two cross sections and the crossing itself. You can see that the cross section is now much longer than before. The opening appears correct, and I also added two relief culverts into the model, so I don't want to have to redo this. I would just like to copy it from this model to the new one. So the way this is done is select those items that I would like to copy. It's a little tricky because I need to get these two cross sections. Or actually, what I'll do is I'll copy the cross sections first. So I'll select those two, go to global copy, two are selected, and I want to copy this to our Pine River model and the existing geometry. So I'll click OK. Alright, so now we go to the Pine River model, and you can see that those two cross sections have been added. So now I want to add the bridge. So I'll go back, click the bridge, global copy, one selected, and I want to go to Pine River existing. Okay, so I'm going to close this one. Do you want to make changes? No. And we're back in our current model, and the bridge has been copied over. So that is good. Now what I also did in the model is I set the bank stations to their correct locations. I added the culverts, and I modeled the bridge opening per as-built. So let's see if that I'm gonna save it and see if it runs. Okay, looks good. I have made some revisions, including specifying the bank stations along the channel. I changed the Manning's end for the channel and revised the overland flow lengths. So now I ran the model, and what I would like to do now is create a depth map. So the way to do that, I will go to results, flood map. I'm going to pick I'll go under options and click here, create flood depth grid, and go OK. Okay, so now this is the extent of the flood line, but what I want to see is the actual the flood depth. So I clicked here depth grid for existing conditions. Click on this, elevation fill, and now if I just click OK, it fills it with these colors. But I would actually like to see where the flood depth is less than or greater than 0.8 meters. So I'll go back here, and I'm going to change these intervals a bit, or this has to be user defined first. I'll put in 0.8 meters, and then for everything deeper than 0.8 I like to show in dark blue. So I'm going to pick dark blue for all these depths. And the only one that I want showing green is this one for less than 0.8. So I'll pick this one here. Okay, so this shows me that this area has a flood depth of 0.8 or less than 0.8, and it's a little bit in green here too, so this would be here we're at 0.6, 0.67, 0.3, so there's a bit of an bit of part of the site that is outside of the 0.8 meter depth, which is sort of like a critical depth for development to be permitted. So if I look at the previous map, like the original map, there's much less green than under the revised existing conditions. So that's going to make the client happy that you got some more of the property out of the floodplain. And you can see here there's actually an access route here, which is all less than 0.8 meters, and that was sort of the objective of this analysis.